In this video, I will try to take a look at the lower division assistant, that is the previous year paper, and we will try to solve the aptitude question. So let's take a look at our first question. The least multiple of 7, which leave a remainder of 4 when divided by 6, 9, 15, and 18 is. So we're given 4 options. Is it option A, option B, option C, or option D? I want you to take a closer look to this question. We will try to solve it like step by step. But first, I want you to take a look at this question because this question contains two set of conditions, meaning two separate conditions. The first one is the least multiple of 7. So the question is asking us to find the least multiple of 7. Now what that means is that the question is asking us that we need to find any number that when we multiply, it divides exactly evenly so that it does not leave any remainder. So the question is asking us to find a number that when I divide, it does not leave any remainder. For example, if the number is 14, 7 2 would be 14, and there's no remainder. If it's 21, the 7 times 3 would be 21, so there's no remainder. So when it is divided by 7, it divides exactly with no remainder. Now let's move on to the second part or the second condition. It's connected to the first condition. Let's take a look what it says. In the second condition, it says that we need to find a number, the same number, which leave a remainder of 4. But this time, it's asking us to find a number that leave a remainder of 4. But this time, it is divided by 6, 9, 15, and 18, not 7. So you can think of the number. It must be similar to the first condition. So when I divide by 6, 9, 15, or 18, the remainder should always be equal to 4. So the divisor change, but the remainder should always be equal to 4. So the first step we need to do is actually take the common multiplier, meaning the common number that is multiplicable throughout all the numbers here. So we can use the LCM. So the first number, if we do the LCM, which is 2 times 3, to simplify it, if you look at the lowest common multiple, it is 90. Now, if you look at the multiplication table, you could see that 6 times 15 equal to 90. And 9 table, that is 9 times 10 would be 90. For 15 would be 15 times 6 would be 90. 18 times 5 would be 90. So as you could see, the common multiple or the number that shows up on all the other multiple, which is 6, 9, 15, 18, is 90. So the least, meaning the smallest number, which is that come up first in every table, is 90. So that is the least common multiple. So it's similar in throughout all of the table or the number from 6, 9, 15, and 18. Now, the least multiple of 7, which leave a remainder of 4 when divided by 6, 9, 15, and 18. So this is our question. So we need to find that number. So let's do the 7. So 7 times what would actually give me a remainder of 0. And 6 times what would give me a remainder of 4. Basically the same thing. Alright, let's the number. I want to say the number equal to n. The LCM we already know, which is 90. The remainder equal to 4. So I can say number equal 90 plus the remainder. So if I add them, the number would equal to 94. Now let's try 94 in our case. So 94 is our number. Let's try to divide it by 6. So 1 would be 6. And the remainder would be 34. So 5 would be 30. And the remainder would be 4, which actually suffices the first condition, is that it needs a remainder of 4. Now let's try 9, 15, 18. Also, the remainder should be 4, 4, and so on, 4. But 94 is not the answer. As you can see, it does provide me the remainder of 4, but if we compare 94, if we use 94 with our first condition, that is the least multiple of 7, this number does not work. Let's see why. So let's say 94, but this time I'm using the 7. So if I do 7 times 1 would be 7. I'm left with 24. 7 13, 7 3 would be 21. If you could see that the remainder it gave me is 3. But this is not what I want. I want when I multiply 7, it gives me a remainder of 0, not any other remainder. So we need to find another least or the smallest number, not 90, but the other one, that is divisible by 7. but at the same time, it's divisible by 6, 9, 15, and 18. We need to try the next value. So I can write 90k plus 4. Here, k can be an index. It's like a list of multiple. In our case, if you notice the table that we just looked, so 6 times 15 equal 90 or something. I don't remember the table, but 9 times 10 would be 90. So that's like the value here, the 15, the 10, the other value that give me the actual value, which is 90. So the k represent that. So 90 times what give me the other least multiple. So let's do k equal to 1. If we do k equal to 1, that would actually give me 94. And we already know that 94 only worked with 6, 9, 15, and 18. But when we try to do it with 7, the condition fails, meaning it only met the second condition, not the first condition. So let's try 2. So if I do 9, 2 would be 18. So that will be 180 plus 4, that is 184. If I try to divide 7, 2 would be 14. And that'll be 44. 7, 6, so 42. Still, this number does not met the first condition, so we know that this is wrong. So let's try the next value, which in our case, we already tried 2, which is 3. So 9, 2 would be 80. So 9, 3 would be 27, plus 4 would be 274. If I try to do 274 by 7, so 7 times 3 would be 21. That'll be 64. 7 9s would be 63. The condition still fails. So we need to move on to the next value. So that it'll be 4. So let's do the k equal to 4. Let's hope this one worked. 9 4 would be 360. 90 times 4 would be 260. Plus 4 would be 364. So let's try this number. 7 times 5 would be 35. I'm left with 14. 7 2 would be 14. As you can see, the remainder is 0. So this number, or the k, it meets my condition. It worked. This 364, the number that we're searching, it worked for the second as well as the first condition. The first condition required that the remainder equal to 0, and the second condition requires that when I divide by 6, 9, 15, and 18, the remainder it give me 4. So let's try with the second condition. So we know that the multiple of 6, as you can see, the previous one. So 6, 15 equal to 90. The second condition is 6, or the second multiple is 6 times 30 equal to 180. But the fourth is the least common multiple, which give me 360 plus the remainder. And the 9 table would be 9 times 10 equal to 90, which we know that it doesn't work. The second least multiple, 9 times 20 equal to 180. The fourth, the least common multiple, that worked, and so on and so forth. So let's try 364 with the second condition, which is 6. Try to divide it. 660 equal to 360. So the remainder it gave me is 4. The second number, which is 9, divided by 40, that give me 360. And the remainder give me 4. So we know that this number, 364, worked with our first condition as well as the second condition. So if we look at the option, we see that option D is the correct answer, which is 364. When we try to solve this question, there's a different approach which is much faster and more accurate. So if there is a time constraint, we probably might want to consider using modular arithmetic, as this process, the modular arithmetic, it solved the problem involve divisibility and remainder. In our case, we are trying to divide as well to find the remainder. So modular arithmetic allows us to work only with remainder and combine multiple conditions efficiently. In our case, we have 2 sets of conditions, and it also helps us to find the least required number or the least multiple number. So modular arithmetic is perfect for this question. If I can, we can try to solve it in the next video. But for now, you can try to solve this question. You can use the same approach, which is find the least multiple of 5, which leave a remainder of 3 when divided by 4, 6, and 12. You can comment down the answer and we'll try to take a look and solve it together. Thanks for watching. See you in the next video.